13. So this is the last one of module 4. Yeah, nice. Okay, points to note. Definition of a photon. I might not have got this in. I kind of described it. I said, discrete quanta form of light in particle form, blah blah. But I think quantum of energy of an EM wave is what they stated. So I think that's, just memorize that. Quantum of energy of an EM wave. When you're talking about photoelectric effect, something I forgot to say is that energy is conserved in the interaction between a photon and an electron. So I said, a photon is incident, it's absorbed by the electron where it's greater than the work function. The electron is emitted off the surface of the metal. But I think, just note it. The photon is absorbed, energy is conserved, the electron is excited. Blah, blah, blah. When you're talking about why it's why K max for photoelectric emission is independent of intensity. Obviously we know and can explain that it's a one-to-one interaction, and it excites it, and intensity is dependent on the number of photons, and it increases the flow rate. But I think sometimes it just wants a more concise way of saying it's it's just, I mean, say that, but also maybe add in, just in case it's in the mark scheme, and the Einstein photoelectric equation, K max is hc over L, or hf, minus the work function, with the work function being the symbol, is it psi, I think? No, that's psi for Greek. Anyway, doesn't matter, just looks like that. Using a subset of a sphere for intensity of a star. I did it, but just worth remembering the 4 pi r squared. It did confuse me a little bit because I drew this diagram to make sure I was correct. And in this diagram, you get this. So you can see that it will become less intense as distance passes. Yeah, that makes sense. But not all of this is going to be instant on the Earth, and then none of the. Because if we're taking it from total radiant power, it's going to be all around here, and there's so much of this just isn't going to get to the Earth. And I think the question was, what question is this? 6. The Earth is so many meters from the Sun. Determine the average intensity of the radiation. So maybe I'm missing something conceptually, because if we have let's say we first worked out the intensity, so the power per unit area, yeah? And then we worked out the power per unit area. Oh, I see. We worked out the power per unit area, modelling it to be, so this is the Sun, here's the Earth. We modelled it to be like this kind of bit encapsulating that. So I guess that does make sense. I thought it's just you're gonna have to model it as a sphere because it's gonna be a proportionality thing, but then I thought, we can see what I thought. I drew the diagram. Then the rest of it is fine. Just remember K max independent of intensity. A little bit of maths. The Planck constant, when you're asked to talk about what that is, I think usually it's just saying talk about the equations, whether it's what did I say? I said the constant of proportionality for the inverse proportional relationship of de Broglie wavelength and momentum, and where the proportionality where the energy of a wave is proportional to its frequency. Not too much there, just get the maths right and remember a few words. Should be okay. Okay, that's all of module 4. Nice. On to module 6 for paper 2. You got this. You got this. I got this. Let's do it.